Welcome to Unit 7, where we explore the fascinating world of renewable energy in agriculture, and how combining different sources of clean power can transform the way farms operate. This lesson introduces the concept of hybrid renewable energy systems, systems that blend two or more renewable technologies, such as solar, wind, biogas, or diesel backup, to create a more reliable and sustainable energy supply. Modern farming depends heavily on energy. From irrigation and lighting to cooling, feeding systems, and food processing, energy touches every stage of agricultural production. Yet, traditional energy sources like diesel and grid electricity can be expensive, unreliable, and environmentally damaging. Hybrid renewable systems offer a smarter solution. By using multiple renewable sources together, farms can reduce dependency on fossil fuels, stabilize their power supply, and make better use of natural resources available year-round. In this unit, we'll explore the different hybrid configurations, real-world examples, and the technologies that make them possible. You'll learn how solar and wind complement each other across seasons, how biogas from farm waste can generate clean energy, and how even diesel can play a role as a reliable backup. By the end of this session, you'll understand not only how hybrid systems work, but how they are revolutionizing energy use in agriculture, making farms greener, more efficient, and more resilient to the challenges of climate and demand. Before we dive in, let's outline what you'll learn in this module. By the end of this lesson, you'll be able to understand the purpose and benefits of hybrid renewable energy systems in agriculture, identify the most common hybrid configurations, such as solar wind, solar biogas, and PV diesel systems, explain how these combinations address the limitations of single energy sources, recognize real-world examples that demonstrate hybrid systems in action, describe how grid connection and integration enhance efficiency and profitability for farms. These objectives will help you focus on the key takeaways: energy reliability, sustainability, and innovation. As we move through each section, think about how these systems could be applied to different types of farms: small family operations, commercial greenhouses, livestock farms, or remote agricultural sites. Each of them can benefit from a well-designed hybrid energy approach. By the end of this module, you'll see how the future of agriculture is not just about producing more food, it's about producing it more efficiently, with clean energy driving every process. Hybrid renewable energy systems represent one of the most innovative and sustainable approaches to modern energy management in agriculture. These systems combine two or more power sources, typically solar, wind, biogas, or even diesel backup, to provide a balanced, reliable, and efficient energy supply that adapts to the changing conditions of farm life. In the agricultural context, energy demand is rarely constant. It shifts with the seasons, the time of day, and the specific operations taking place on the farm. Irrigation pumps, cold storage units, feed mixers, and greenhouse ventilation systems all require power, often at different times and intensities. A single renewable energy source might meet these demands part of the time, but not consistently. This is where hybrid renewable systems offer a powerful solution. By integrating multiple technologies, such as solar panels that capture sunlight, wind turbines that harness air movement, and biogas generators that convert organic waste into fuel, farms can create a continuous and flexible energy supply. When one source decreases in output, another can take over, ensuring that there is always sufficient power to maintain operations smoothly. This reduces the risk of downtime and enhances the farm's overall resilience. Each renewable source contributes unique advantages. Solar power is abundant and predictable during daylight hours, especially in summer months. Wind energy can generate power both day and night, often peaking during cooler, windier seasons. Beta Biogas systems convert manure and crop residues into energy, offering a reliable base load that operates independently of weather conditions. When combined intelligently, these sources complement one another, smoothing out fluctuations and reducing reliance on large battery systems or fossil fuel generators. For example, during a calm but sunny day, solar panels carry the load. At night, stored biogas or wind energy keeps operations running. And if both renewables drop temporarily, a small diesel backup can fill the gap. Hybrid systems can operate in two primary configurations, on-grid or off-grid. On-grid systems are connected to the national or local power network, allowing farms to export surplus electricity during periods of high generation and import energy when renewable output is low. This two-way interaction can lower costs, stabilize income, and even generate profit through net metering programs. Off-grid systems, on the other hand, are designed for remote areas with limited or no grid access. These systems make farms fully self-sufficient by storing energy on site and managing production intelligently based on weather forecasts and demand patterns. Agriculture is unlike any other sector when it comes to energy use. A farm's power needs are dynamic, constantly shifting with the seasons, the weather, and even the time of day. Unlike industrial plants that operate with consistent energy loads, farms experience patterns that depend entirely on nature and production cycles. During hot, sunny days in summer, energy demand often spikes as irrigation pumps run continuously to keep crops hydrated. In contrast, during colder or wetter months, farms may require energy for heating barns, powering ventilation fans, or maintaining greenhouse temperatures. Livestock operations might need steady electricity for automated feeding, lighting, and climate control, while processing facilities rely on continuous refrigeration to prevent spoilage. This variability creates a major challenge. Traditional single-source renewable systems, such as solar-only or wind-only setups, cannot always match fluctuating demand. Solar energy, for example, performs excellently on clear days but drops significantly during cloudy weather or at night. Wind power can produce energy 24 hours a day, but only when wind speeds are favorable. Biogas generation depends on the availability of organic material and system conditions. Each renewable source has moments of strength, but also periods of weakness. Hybrid renewable systems provide the solution to this challenge by combining multiple complementary energy sources. When sunlight is low, wind power or biogas generation can fill the gap. When both renewables drop, perhaps on a calm, overcast day, stored energy from batteries or a small diesel generator ensures that operations continue without disruption. This layered approach to power generation allows farms to maintain stability, flexibility, and independence from the grid. For example, a farm might rely primarily on solar panels during the day, draw on wind turbines at night, and use biogas from livestock waste as a consistent baseline source of power. Battery systems store surplus energy to handle short-term fluctuations. Together, these technologies form a balanced ecosystem, one that adapts in real time to changing weather and operational demands. The advantages extend well beyond reliability. Hybrid systems reduce the need for oversized battery banks, which are often costly and require maintenance. They lower fuel consumption by minimizing the reliance on diesel generators, significantly cutting operational expenses and carbon emissions. They also enhance long-term energy security, ensuring that farms remain functional even during grid outages or volatile energy markets. Furthermore, hybrid systems play a critical role in supporting environmental sustainability. By integrating renewable sources with waste-to-energy technologies like biogas, farms can recycle organic materials into useful energy. This reduces methane emissions from decomposition and helps close the loop between energy use and production. In essence, hybrid energy systems make agriculture smarter, cleaner, and more resilient. They allow farmers to manage their power supply proactively rather than reactively, aligning energy generation with farm activities in a seamless, automated way. Whether for irrigation, refrigeration, milking, or greenhouse management, energy is always available when it's needed most. By embracing hybrid renewable technologies, farms are not only securing their productivity, they are investing in a sustainable, affordable, and independent energy future. Hybrid systems are transforming agriculture into a model of efficiency, adaptability, and environmental stewardship for generations to come. Hybrid renewable systems come in different configurations, each designed to suit specific agricultural environments and needs. The three most common types are solar and wind, solar and biogas, and PV diesel backup systems. Solar and wind hybrids are ideal for regions with both strong sunshine and seasonal wind variation. Solar panels generate power during the day, while wind turbines often perform best in the evening or winter months. This natural complementarity allows nearly continuous production throughout the year and minimizes battery storage needs. Solar and biogas hybrids are particularly effective on livestock or mixed farms. Organic waste, such as manure and crop residues, is converted into biogas through anaerobic digestion, producing electricity and heat. The solar component supplies daytime power, while biogas ensures energy availability at night or during cloudy periods. PV diesel backup systems are commonly used in remote areas or farms without stable grid access. Solar panels handle most of the load, and diesel generators provide backup energy during extended periods of low solar output. This reduces fuel consumption and emissions while ensuring reliability. By understanding the unique benefits of each system, farmers can select the configuration that best fits their climate, budget, and production goals, achieving both economic and environmental gains. Solar and wind energy form one of the most effective hybrid combinations in agriculture. Solar panels perform exceptionally well during long, sunny summer days, while wind turbines often produce more energy at night or in the winter. Together, they create a year-round balance that provides consistent power generation and reduces dependence on storage. On a farm, both systems can share the same land. Panels can be mounted low, while turbines stand tall, making efficient use of space without interfering with crops or livestock. This combination can power water pumps, ventilation fans, lighting, and processing machinery, covering a wide range of agricultural energy needs. Another major benefit is the reduction in operational costs. Once installed, solar and wind systems require minimal maintenance and have zero fuel costs. By generating their own energy, farmers can shield themselves from fluctuating fuel prices and grid instability. In essence, solar-wind hybrids turn the natural rhythms of weather into reliable, clean power, perfectly suited to the dynamic energy demands of agriculture. A real-world success story of solar-wind integration comes from Australia. Iberdrola's Port Augusta project, the world's first large-scale wind-solar hybrid plant, combines 210 megawatts of wind power with 107 megawatts of solar energy. The facility includes 50 wind turbines and 250,000 solar panels, operating in harmony to supply stable electricity to thousands of homes and industries. What makes this project so groundbreaking is its efficiency and scalability. By combining two renewable sources with different production patterns, Iberdrola ensures round-the-clock energy generation and grid stability, even during fluctuating weather conditions. The same principles apply to agricultural operations on a smaller scale. A farm that installs both solar panels and a few wind turbines can achieve similar benefits: reduced storage needs, lower costs, and higher reliability. This Australian project demonstrates that hybrid systems are not just a theory, they are a practical and proven path to sustainable energy independence. Biogas systems transform organic waste, manure, crop residues, and food byproducts into renewable energy. When combined with solar power, they form one of the most sustainable hybrid models in agriculture. During the day, solar panels provide electricity for irrigation, feeding systems, and lighting. At night or in cloudy conditions, biogas systems take over, producing heat and power through anaerobic digestion. This ensures that farms always have access to clean, renewable energy, even when sunlight is unavailable. The benefits extend beyond energy generation. Biogas systems also reduce methane emissions, improve manure management, and produce nutrient-rich fertilizer as a byproduct. When integrated with solar power, they close the loop, turning waste into energy and energy into productivity. Solar biogas hybrids are especially valuable for livestock and dairy farms, where organic material is plentiful. They promote circular economy principles, turning what was once waste into a reliable source of power and income. Germany's first solar biogas hybrid plant stands as a powerful example of how renewable energy can integrate seamlessly into agriculture. Producing 7.4 megawatts of thermal power, the facility injects biogas directly into the natural gas grid while using solar panels to generate electricity. The system uses waste from surrounding farms as feedstock, turning it into biogas that fuels engines and provides heat. During sunny periods, solar electricity covers operational demand, while biogas ensures continuity at night or in cloudy weather. This combination maximizes efficiency, reduces emissions, and supports both local farmers and national energy goals. The German project proves that hybrid systems can be scaled, from small family farms to industrial-level energy producers. It showcases how renewable integration can achieve both environmental sustainability and financial viability, serving as a model for future agricultural innovation. In remote or off-grid farms, reliable power is essential. PV diesel hybrid systems combine renewable and conventional energy to ensure continuous operation, even in challenging environments. During daylight hours, solar panels supply most of the electricity. When solar generation drops, for example, during storms or long cloudy periods, diesel generators automatically start, covering the gap. This setup drastically reduces diesel consumption, fuel costs, and emissions while guaranteeing reliability. PV diesel systems are ideal for farms that require consistent energy for critical processes like refrigeration, water pumping, or grain milling. They also allow for gradual transition. Farmers can start with a diesel base and add solar capacity over time, improving sustainability step by step. By blending renewable and traditional energy sources, these hybrids deliver stability and flexibility, a crucial combination for agricultural productivity in remote regions. The Sandfire copper and gold mine in Western Australia operates one of the world's largest PV diesel hybrid energy systems. Located in a remote, arid region, the facility combines a massive solar array with advanced diesel generators to ensure continuous, efficient power supply. This hybrid system has significantly reduced diesel use and carbon dioxide emissions, cutting costs while maintaining reliability, even during extreme heat and variable sunlight. For the agricultural sector, this case illustrates how similar systems can provide dependable power in isolated locations, supporting farming communities that are far from national grids. It's proof that renewable diesel hybrids are practical, scalable, and essential for transitioning to cleaner energy without sacrificing performance. Connecting renewable energy systems to the grid transforms farms from energy consumers into energy producers, or prosumers. By exporting surplus power and importing when needed, farms can balance supply and demand efficiently while earning additional income. Successful grid integration requires careful planning, assessing energy demand, ensuring voltage compatibility, and complying with local grid standards. Smart inverters and meters enable real-time monitoring and seamless power flow between the farm and the grid. Net metering programs make integration even more beneficial, allowing farmers to offset energy costs by selling excess power. Although some rural grids may face capacity challenges, the long-term benefits, lower bills, improved sustainability, and greater energy independence, far outweigh the initial setup complexities. Through grid connection, hybrid renewable systems become part of a larger, smarter energy network, one where farms play an active role in shaping a sustainable future. The future of agriculture is hybrid. As farms become smarter and more data-driven, energy systems must be equally adaptive and resilient. Hybrid renewable technologies are leading this transformation, offering flexibility, lower emissions, and long-term cost savings. Imagine a farm powered by solar during the day, biogas through the night, and wind in between. Smart grids automatically manage power flows, and digital monitoring tools adjust operations based on weather forecasts. This vision is no longer far away, it's already being implemented worldwide. Hybrid systems empower farmers to be both producers and protectors of energy, improving sustainability while maintaining productivity. They represent the bridge between traditional agriculture and a future where every farm contributes to a cleaner planet. Thank you for joining us in this exploration of hybrid renewable energy systems in agriculture. We've learned how combining multiple energy sources, solar, wind, biogas, and diesel backup, can create efficient, resilient, and eco-friendly power solutions for farms. Hybrid systems aren't just about energy, they're about empowerment. They help farmers take control of costs, improve reliability, and protect the environment for future generations. As technology advances, the opportunities for sustainable farming grow even stronger.